G'day, this video will be covering another fundamental law of electrical engineering, which is Kirchhoff's Voltage Law, or KVL. Now, KVL states that the sum of the voltages around any loop or mesh is zero. That is, the sum of the voltage rises is equal to the sum of the voltage drops. Now, we define current as passing from negative to positive polarity in voltage sources, and from positive to negative polarity in voltage loads. So in this circuit, we'll draw on our polarities. We have Vs as a voltage source, so our current would be passing from negative to positive. We have our two resistors, R1 and R2, which are voltage loads, so we have passing from negative to positive polarity, and then from positive to negative polarity, and then from positive to negative polarity again, so that we have a voltage rise, which is equal to a voltage drop, and then a second voltage drop, which will equal out. So a way of thinking about it is, if you're at a particular location and you need to climb up a mountain and then come back down to a particular location and then come back to where you started, then the amount of distance that you've climbed up is equal to the same amount of distance that you've gone down again to get back to the same place. And that's how KVL works. So our expression here is Vs is equal to, now we'll define this current as Is. Now, given we have Ohm's law, which is equal to V equals IR, the voltage across resistor 1 is Is R1, and then we have another voltage drop, which is Is R2. Now we do a little bit of algebraic manipulation to get Vs equals Is R1 plus R2, which, by manipulating it through Ohm's law, we now have an expression which we will be able to solve for the unknown current Is, given we already have the voltage Vs and the two resistances, which is, to solve for Is, we rearrange to have Vs over R1 plus R2, which is equal to 5 volts on 25 plus 25 ohms, which 5 on 50 is 0.1, which equals 0.1 amps. Now this becomes a lot more useful later in nodal and mesh analysis, and it's a fundamental understanding requirement for being able to tackle those larger, more complex problems. So, the sum of the voltages around a loop is 0, rises equals falls. So that was a down and dirty for KVL. If you have any questions or comments, please leave them below. Otherwise, I will see you in the next video.